We're going to be talking about updating the Vex IQ firmware, downloading and installing the Vex code for Windows, creating your first program, improving that program, making additional little features and fixing bugs, that sort of thing. We're going to add some semi-autonomous features to the program, things like telling the arm to go to a specific position versus just telling it to go up and down. We can say go to the high position or go to the low position to drop the cube or the game element, that type of thing. We're going to do a little bit of simple autonomous programming. So that's where we get rid of the joystick, and now kids can do for their skills. They can create a simple little autonomous program that maybe scores a few points or something like that. Be able to pick something up, move it, score it back up, turn around, go different place, do something else. We'll go over the sensors a little bit just to kind of introduce you to what all the other sensors are, and then we will have some time for some questions, things like that. So the first part, updating the firmware. Why do you want to do this? Well, you may not have to do it. You may get the robot. You purchased the robot, built your basic little clawbot or whatever instruction kit or something of that nature, and it may work just fine. You turn it on, no complaints. But you could turn it on and it says something like motor out of date, or you could plug in your joystick and your and do your pairing of your joystick controller to the brain, and it could say that one or the other is out of date or something like that. And typically Vex will update the firmware to these maybe twice a year, maybe a little more, something like that. But every one of these things, the brain has software in it that runs. Each one of the motors has software inside there that runs. The different sensors, whether it's, say, one of the light sensors, the LED touch sensors, all of the different components, the joystick, all of these have their own sets of firmware that run inside each one, and they all need to be up to date so that they can talk to each other in the way that they're expecting to talk to each other and not be running old code or something like that. Also, they make changes, fix bugs, sometimes introduce bugs, but hopefully generally fix bugs, that sort of thing. So there might be times where you need to update. Probably the best time to do an update is at the beginning of the season. I don't really recommend updating all of the time, like just before a tournament or something like that, because it's kind of risky. Things might change, might possibly stop working. Like I said, they could introduce a bug or something like that. So try doing your updates at the beginning of the season. If you need to update again, like somebody's telling you should update, or you're having problems, then maybe update. Otherwise, you probably don't need to, and you can go through the rest of the season without updating. But to get the update software, Vex has a utility called Vex OS for Windows. And you can do a Google search for Vex IQ firmware. Here's a link here to Vex Robotics to find the Vex OS software. You can, once you go to that web page, you click the download. Let me find this web page. There we go. Here's the web page that has the software on it, updated in February, not too long ago. Click the download Vex OS for Windows. There's also a Mac version. Now this utility does not work for Chrome or tablets or anything like that. You need either Windows or a Mac. So you can download that, install it, and then the next thing that we do is we run the program. So I'll start the program up. And here it is. So all it does is it sits there and looks for a brain. And the way that you connect the brain up is through the USB port. There is a micro USB port. Be very careful with these when you're plugging it in. But this is the way to update firmware and even to program, for students to program their robots and things like that. So plug that in and we will turn it on. And it will hopefully recognize, there we go, USB connection failure. Imagine that. So sometimes it works, sometimes it doesn't. I'm going to turn it off. And I'm going to turn it on again. And there we go. We're somewhat happy. Okay, so what this is showing is it is showing what is connected to the brain. So right now we have the brain, we have the radio, we have 3 motors, and it's giving you the option here to install and update all of these things. Now what we really want to do is we want to connect all of the other components that you might have. So you know your kit came with 4 motors or 6 motors or something like that. Go ahead and plug in all of the motors and all of the other sensors, the touch sensor, the light sensor, that sort of thing. Now some of these don't actually show up as we're plugging them in. So I got here a light sensor. I'm going to just plug that in. Just plugging these into any random port, doesn't really matter. I'm going to go ahead and just shut this off for the moment. There we go, turned it off. I got, this is the light sensor, color sensor, line following sensor, whatever you want to call it, does all those things. The other thing we want to do is we want to plug in the joystick or controller. And that plugs in through this Ethernet jack. This is this funny big blue cable that they gave you. Plugs into the back of the brain, and then that then plugs into the back of the joystick. So we get this plugged in. Don't plug this directly. I know this has a USB cable, micro USB port. This is just for charging. Don't plug that into the computer there. I mean, nothing will happen, but and also this is an Ethernet port. Don't go plugging that into some sort of Ethernet jack or your computer Ethernet port or something like that. This is just for plugging it into the brain. It's used for pairing the two, and it's used for programming. So now plugged everything in, I am going to turn the brain on, and connection failure again. And look, it's even saying on there one of the color sensor needs updated. Let me shut it off. Turn it back on. And there we go. Okay, so we got a few things that need updated. Up now it shows the joystick there. Looks like even the thing. I want to hit install, and it's going to start installing. Now, as it's installing, it may shut off. So you may kind of keep an eye on the brain. You may see the light turn off as it kind of does things. So actually it says press power on brain. It is on still, even though it shows that it's saying that it might be off. So I'm going to turn it off, and I'm going to turn it back on again. Press power to brain. So it is not recognizing that. Connect to PC for program update. Let's try this again. I'm going to disconnect it this time from the USB, and let's plug it back in, see if it is happy there. Nope, still not happy. Okay, so update, release power, shut it off. I'm going to close this software. And we are going to start it up again. And turn the brain on. There we go. Okay, so something came back anyway. It doesn't show any of the devices. It's really in kind of a very messed up infant state here. So let's hit install. Hopefully it's going to update the brain a little bit. Connecting, rebooting, installing. Update needed. Do not unplug cables. Yeah, so when it does say do not unplug, just leave that alone because it might mess things up. Let's see if this is making progress or not. showing here on the brain saying update needed for the color sensor. I'm just going to hit X out of here. Smart radio must be updated. I'm going to hit X. And I'm at the main screen. And it's telling me to not unplug any cables, but I sure don't see it doing anything. So normally I would say you really don't want to unplug this because you could potentially brick your device, but it's also kind of hosed. I'm going to shut her off. Okay, turned it off. I'm going to turn it back on. Continue. And now it sees more things. I'm going to hit install. Let's see here. Okay, looks like it's actually doing something. I see a progress bar here on the screen. Yeah, contrast ain't gonna let that work very well. There we go. Do not unplug. Now I can see the progress bar moving. Now we don't want to do anything with this. We'll just let it sit and hopefully it'll make progress. Still says installing. Progress is moving. So one of the things and one of the reasons why you may want to go ahead and update your motors and everything now is because in the middle of the season, the students could, say they want to add a motor, they go grab an old motor that hasn't been updated in the last 6 months or something like that. They're likely to plug it in, try to use it, and it says motor out of date, please update firmware. And so they're coming to you saying, please update the firmware. This is still showing a progress bar. It's not going anywhere, but I'm going to still give it some time. It might be still doing something. This is also, as you can see, I kind of had to fiddle with this a little bit. There we go. We got the sound. Now, what it did do is it erased all of the programs on there. That is one thing that it sometimes does when you are updating the firmware. So you got to be careful of that the kids do have their software saved somewhere and they can reprogram the brain with their driver program or autonomous program after you do an update, because when you do the update, it could possibly erase everything that's on there. So there we go. We have that stuff on there. And like I was saying, you want to go ahead and update all of your different components for the robot, because if they go sticking it on later in the season, they may find that they're out of date and you have to then update it for them. And the system is a little bit tricky. So this is just something that I do. I usually do it with the kids or something, but I'm kind of the one doing this. And I very much believe in the kids owning everything and owning how to program and owning how to, debug their robot and all that stuff. But when it comes to these firmware things, I just kind of deal with that. Historically, it's been very difficult with the high school stuff, very complicated. And even those kids really struggle with it. This is much better, but as you can see, it still has a little bit of tricky problems with it. We've updated all of the firmware on here. I'm going to go ahead and unplug the brain from the joystick, unplug the extra motors that we have there. Now the next thing, we're going to install the software that the students will use to program their robot. And the software that I suggest using at this point is the Vex Code IQ Blocks. It's a graphical based program. It's free from Vex, and it's pretty easy to use. It's pretty new. Last year was really the first year we ever even tried using it. And they're making good improvements, and it's quite usable now at this point in time. So you can go to this link to download the Vex software. Here on the web page, here's the downloads. This is there's the high school stuff. There's Vex Code VR, and then here's the Vex Code Blocks. Now, for this, it is available for Windows. It's available for Mac. It's available for Apple-like tablets. If you got a large tablet, it works kind of quite nicely for Apple or Android tablets. We actually, for our classroom, we have 6 tablets that the kids use to program them. The nice thing about the tablets is that you can actually program them wirelessly through Bluetooth, which is really nice. Downsides, the Bluetooth connection stuff is a little bit wonky sometimes. Keeping all the tablets in sync with whose programs on what tablet and that sort of stuff can be a little bit tricky and things like that. And then I believe this is now also available on the Amazon Kindle. So that's really good. But you can download the Windows here, and then or the Vex Code IQ Blocks for Windows, and then you can install it. Once you have that installed, we will go ahead and start up that program. When Vex Code IQ Blocks starts up, it starts up with an empty program. If you have something you've already written, you can go to File, Open, or Open Recent to load in that program. Otherwise, if you're starting new, first thing you'll want to do is go up here and change its name. For what I recommend for robots, that every team has their own directory, so then that way teams can have multiple programs and they're not potentially conflicting with each other. And then I, as a coach, I know where to go to find that team's programs and stuff like that. So this team was 520M. I have a 520M directory here. And I'm just going to call this bot drive. So maybe they have a name. They've named their robot. Maybe they've named it Johnny. Maybe they've named it whatever sort of name, and you can call it Go Johnny or Go whatever the name that they want to name the robot or something like that. Hit save, and so now you have your robot or your program named, and it will automatically save. There's actually no save button on here. It will just automatically save. So here in Vex Code IQ Blocks, over on the left-hand side is a list of all the commands, and we can kind of scroll through here. You can see all of them. There's lots of different ones for doing math and other conditions and loops and things like that. What you notice right now, you don't see anything for commanding a motor, turning on lights, or doing stuff like that. That's because we don't have any of those items added to the program here. So every one of your different components needs to be added. And over here on the right hand side, there's this little picture of a port that's like the ports on the brain that you plug in. You can click that and you can add your component or device right here. So for instance, we can start with a drivetrain, the kind of the first thing that you have. And this is the drivetrain, just kind of simplifies things. Drivetrain consists of 2 or 4 motors. You have different options up here of selecting what type of drivetrain and which motors. Now, for selecting the port, when you build the robot, it really doesn't matter which port the motors are in. It's just you have to select the right ones here. When it comes to the predefined driver control, that's when they want certain motors and certain ports and things like that. But the great thing here about programming is you can do whatever you want, and the kids can plug them in based on how they're conveniently located and that sort of thing. So for this robot, we're going to follow the motors through. It's asking for the left motor. And so now the robot's left side, this is its motor, and it runs up, plugs into port 6, it looks like, for the left motor, and the right motor plugs into port 12. We'll remember that. Over here, left motor is port 6, right motor is port 12. Gyro, this, we're not using a gyro. Most people will not use a gyro, and there's not a lot of need for it. So then here's your drivetrain settings. Inside here, you can specify what wheel diameter is being used. You can specify the track width, the wheelbase, so the distance apart the wheels are, things like that. Even potentially the gear ratio. And let's get my focus back in here. Even potentially the gear ratio in that. Now, this isn't that important when it comes to driver, but when it comes to autonomous, where you're telling it to try to go 3 inches forward or trying to tell it to turn 90 degrees and stuff like that, there you really need to kind of tweak these numbers so that a way the robot does what you expect, because you don't want the kids saying, you know, to make it turn 90 degrees they really have to tell it to turn 115, you know, or something, some odd strange number, and then always have to remember that. So this is a way you can kind of tweak and do that stuff. So now you have your drivetrain, and so then you can see over here on the left hand side, now there's drivetrain commands for telling it to drive forward, turn right, that sort of thing. Next, over here on this robot, we have an arm. This just has a single arm, one motor on it right over here. And so we are going to add a motor. And we're going to select its port. And this motor is plugged into, looks like, port 9. So select 9. Now, here's some really important parts that a lot of kids skip and they miss this, and this really is valuable to go ahead and do this now, so that kids then when they program everything will look nicer, will make more sense, be easier to read, and that is naming your motors. See, this just calls it motor 9. Well, when you end up with a whole bunch of motors, you could have a claw motor, an arm motor, you could maybe have another motor that does something else, or, you know, causes it to strafe side to side or do whatever. When you have all these different motors, when they're just called 1, 2, 3, you don't remember what they are. So for this case, call it an arm motor, right? So now all of your commands and everything you're going to specify for the arm motor. The other really, really important and very valuable thing, I can't stress this enough, is now you can give labels to the directions. I mean, what does a motor do? A motor turns clockwise or counterclockwise, right? They're saying, well, it could go forward and reverse, but what is forward and reverse? Well, they're showing you it's counterclockwise or clockwise. But as an arm, what does the arm do? You know, if it's a claw, what does the claw do? Does the claw go forward and reverse? No, the claw probably opens and closes. The arm probably goes up and down. So give it those useful names, and the students will then forever in their program over here, they'll tell it and command it to go now up or to go down, versus telling it to go forward. You know, telling the claw to go forward. Well, what does that mean? Well, I think it means it's open, you know, and they figure that out, but then a week later they forget, or then a month later in the competition when they're trying to frantically make a change to their program, they select the wrong direction, they hit program, they run out to the field, they go run it, and you know, they mess up on that match because they changed it and made it, you know, go the wrong direction because they forgot that reverse means open and forward means close, or something like that. So here, have them figure this out. And, you know, they could guess and then they could check, and if it goes one way, then they go swap it or something like that. But it's actually really easy to figure this out. You can look at the motor. So in this case, I have the motor over here, and it shows a picture there on the screen of, you know, the motor rotating counterclockwise or the motor rotating clockwise. And so what I'll do, especially with the younger kids, is I'll say, okay, I'm going to move the arm up. Now you watch which direction the motor is. And they look at it from the orientation of the picture that it shows. And they look, and so I say, okay, now we're going up. Is the turning, because, you know, there's gears. The gears change, cause the direction to change and things like that. So don't watch the gear of the arm. Watch whatever the gear of the motor is. As I go up, and I go up, is the motor moving clockwise or counterclockwise? And okay, let's try it again. Is the motor moving clockwise or counterclockwise? And they kind of look, and you try it 2 or 3 times. They figure, okay, so now as it's going up, the motor is turning counterclockwise. Okay, so over here, counterclockwise is this one, so this is going to be up. And then by default, then the other side is down. So now the great thing about this is when we add the commands over here, let me hit done. And so now we have ARM commands over here. And we can say ARM, where is it? ARM spin up or down, right? That's great. That makes great sense. And so here it says ARM versus saying spin motor 3, forward, right? We can say spin arm up. It's much more readable. It's much easier for kids to not make mistakes, that type of thing. So now we have a drivetrain and we have an arm, and really that's all there is on this motor, on this robot. But there is one other component that we need, or device we need to add, and that is the controller. And I suggest actually kind of adding this last, because now in the controller it gives you an option when you select you want the controller, a simple way of, I want to select these buttons to do this and these buttons to do that. And so if you have a motor in there, it allows you, it's very constraining, unfortunately, and this doesn't really allow the kids to make mistakes or do things that kind of really don't make sense, which is this is a great opportunity for kids to learn that, making the joystick or pushing this button on the right makes the robot turn left, is very confusing, and maybe they need to design their interface so that it's, easy for everybody on their team to drive and stuff like that. But they still can select what they want these buttons to do, whether these buttons here make the arm go up and down, or you kind of got to click around. This interface is a little funny, but so maybe we want these buttons here on the back to make the arm go up or down. We can swap it to make it go down or up, and whichever direction we want. Then the drivetrain, really, you only have the choice of using these joysticks, so you can't make the arm go up and down with the joysticks at all. You just have to simply use the buttons for, say, for the motors, and for a drivetrain you can use the joysticks. Let's just say for this one we want just this right stick to make it go forwards and left and right and that sort of thing, and then over here on the left, their left hand is just using the arm buttons or something like that. So we hit done, and that's basically it now. So now we're ready to download it to the brain of the robot and run the program. There's something, though, that we want to select first, and that's over here. There's slots. And on the brain, there are 4 slots. And basically, there is room for 4 different programs on your robot. A lot of kids are going to start out, they're just going to have this one driver program, but they're going to say then add an autonomous program. Maybe it just does some simple little autonomous thing or something like that. Then and so you put the autonomous program in slot 2, your driver program in slot 1. Then maybe they add a, super fancy autonomous program and it's in slot 3, but it doesn't always work. So, in competitions, you have slot 2 for their regular conservative one, and then slot 3 is kind of for their advanced one, and maybe slot 4 is for some experimental stuff that they're using and things like that. So they can add 4 different programs on here that can be on the robot all at the same time, and so when they turn it on, they can select which program they want to run. But you do have to be careful so that the students don't overwrite the the driver program with the autonomous program or something like that. So make sure that they're paying attention to what slot they're wanting to program it in, because they can just go through and save the same program onto all 4 slots and override everything that's on there. So selected the slot, and then now we want to select download. It's actually grayed out. I do have the brain plugged into the USB here on the back, but I need to turn it on. So let's turn the robot brain on. There we go. Brain turned green, and now I can click download. And I guess it's done. It didn't really give much indication. Now, for the first time when kids go driving their robot, I strongly suggest doing things like removing that USB cable because it's very sensitive to being pulled and yanked the wrong way. Also, I suggest really putting their robot on a table on an actual field with walls versus say on their desk or on something where it can fall off, because they're now going to start driving their robot and it could do who knows what from what different things. So with it unknown, they need to be very careful about it. So I got to turn on the joystick here, and then I can hit run up here in the corner after I've downloaded it right there, and now you can see it's flashing and running. Or I can select it on the brain and hit run there. So now let's see. We made these buttons here control the arm. This one was supposed to go up. There we go. It goes up and down. Okay. Up. So it goes up, but it does seem to kind of fall back down there. Okay, let's try driving. Okay, it moves. I tell it to go forward and it actually goes backwards. I tell it to turn right and it turns left. And so you can see here, if the kids think they're going to drive forward and they drive forward, but instead the robot just drives off backwards right off the table, that could be a problem. So I really suggest them, using a field that has walls to protect it. So we have a couple issues. The arm doesn't really want to stay up and it changes direction. So in the controller, we look here, there's really nothing for configuring any sort of directions in there. But go to the drivetrain and there's this arrow. So these arrows, you can actually click the arrows that way or that way. I think this means basically make it reverse. So let's click done. Let's click download. Click on run. And I'll try it again. There we go. Now forward is forward, reverse is reverse. I turn it right and it goes right. I turn it left and it goes left. Excellent. Okay. And still have the problem. It'd be nice if the arm stayed up, because if I'm going to pick something up there, I would want it to stay up. So it doesn't really do that. So what we have over here on the side under motion, there's some potential different configurations and different options here. We can tell the arm to go up, go down, set its velocity. So let's say the arm is going really fast or something and we want to slow it down. I'm just going to put it kind of exceptionally slow here so we see it going slow. Maybe max torque. Okay, so max torque is basically the force. Let's say this is an arm and we really need to make sure it has a lot of strength, so we're going to put that at 100%. Now when they're initially testing things out, they may want to put this low so that they don't break something, right? Because when they go hit one of the hard limits or hit the side, something could break depending on how durable the design of their robot is. Here's a setting. This is called arm stopping to, and then what the options are: brake, coast, and hold. So this is what does the motor do when it's told to stop. And it looks like it's default set to brake. Coasting would be as if like you're driving and you just put it in neutral type of thing. And then hold is, stay where you're at. And that's what we want here, is we want to tell the arm to hold its position. Once we tell it to stop moving, we want it to stay where it's at and not just go into a free fall or something like that. So let's hit download and let's hit run. And now I'm going to move the arm up. And there we go. So the arm goes up, comes back down. Excellent. And we can pick it up and we can drive if I'm very careful not to drive off of my desk. You can go very slow. Okay, and so now you have the basics of a simple little driver program where the kids can tweak some little settings. Let's say actually now they want it to go really fast. Let's change that to 100. Let's hit download. So the brain stopped once it downloaded. When I hit run, and then so you can see there, now the arm goes really fast. But you can also see that might be out of control, right? We're kind of making a mess of things, and so maybe they really, maybe they don't want it to go that fast. So, you know, let's go put this back down to say 50% or something like that. So then that away, it's, you know, under control. So this gives us some options as to what we do want and things like that. Now the students go to their first competition. They learn a whole bunch about, you know, what worked with their robot, what didn't work. They saw, you know, these other super fancy robots with 2 arms and a claw, and one could pick up 2 of these things at a time, and they got all these great ideas of all these changes and everything else that they want to do. So now they get back to class and practice, and what's the first thing they want to do? They want to add an LED onto the top of their robot, right? So that's what they do. They take an LED, plug it on the top, plug it in the side. I'm going to actually turn the robot off first. Now I'll plug it in. Turn it back on. Okay, so now their robot is going to be super awesome and score so many more points with this green LED that's up on the top there. Okay. So how do we make this program? Well, we first go over here to devices and we say add device and touch LED. Right there it is. And I've plugged it into port 3. There we go. Touch LED 3. Well, I mean, it's the only touch LED, so we can just call it touch LED. Sometimes they'll add 2, right? Because, I mean, after they add 1, they're going to want 2. So, you know, then you'll have maybe the left and the right or something like that. So, but, okay. So we have the touch LED. Now we should have some things over here. I think it's under looks. Print hello, blah, blah, blah. Set touch LED. Okay, so now we can set touch LED color to none. Well, none, I guess, is off. But we can tell it to turn green. There we go. So touch LED green. Let's hit download. Let's hit run. And well, what happened? It didn't turn green. Well, actually, the nice thing about it is the brain on here is saying connect controller. So the program's not actually running because the controller's off. We turn the controller on and voila, it turned green. It's a little hard to see in the camera, but it turned green. So there's actually a good value to having this thing, you know, turn on when the program runs, because one of the common things that happens with students is they turn on their robot, they're up at the they're up at the match, getting ready to start, ref's saying ready, they're saying ready, they give them a thumbs up, we're all ready to go, 3, 2, 1, da-da-da-da, and their robot's not working. What, it's not moving. What's that? They look down at the robot's on, they're like, well, what's it? Oh, they realize their controller's not on, right? So now, here they'll have this indication that the actual everything is on and running once their their controller and the brain and everything is on and running correctly, the light will turn green and they know everything is good to go, type of thing. So there's actually some value in that. Of course, then as soon as they do that, they're going to want it to flash different colors. So they're going to say color green, then they're going to say color turn red, then they're going to say color turn, you know, orange or whatever else, right? And so we're going to go download and we're going to go run and go bloop. Wait, what happened? It's orange. Why didn't I see it flash? Well, that's one of the things they got to learn, is that computers run very, very quickly. So it did this in milliseconds, so fast they didn't see it. So one of the things that they want to do, or will want to do, is add some delays in here. So we can say wait 1 second there, wait 1 second there. So it'll turn green, 1 second later it'll turn red, 1 second later it'll turn orange. And maybe 1 second's too long. Let's make it half a second. Okay, so we can put in here 0.5 or something like that. Download, run, boom, boom, boom. There we go. Okay, so now, but it doesn't keep flashing, right? So it flashed, but then they want it to keep flashing. So what you can do there is you can add a forever loop, because you want it, you just, the program does what it says and then it ends. It doesn't do anything else. So you can go in here and you can add in a forever. Let's get that in there. Okay. So then put all this stuff in here. So now whatever is inside this forever loop is what it's going to continuously do. Forever it's going to repeat. Turning green, waiting half a second, turning red, waiting half a second, turn orange. Then it's going to turn green again, which let's hit download and let's hit run. It goes green, red, green, red, green, red. Wait, what happened to orange? Well, there's no orange. Let me hit stop here. So I don't see it doing orange. Well, what's actually happening is it's doing orange and then it's instantly going right back up here to green a millisecond later. So we need to add another delay in here saying 0.5 and now download and run. And now they have successfully a flashing LED. Now, that's all great, wonderful, blah, blah, blah. What they could do instead is add something maybe a little bit more useful, where they start the program. It waits, let's just say 3 seconds, where they can say 3, 2, 1. Then it turns green. And then they wait, I don't know, let's do a magic number of 60 seconds. And then after that, it turns red. Okay, so what do we got now? Let's get rid of all this. We have a match timer, right? So they hit run, 3, 2, 1. Oops, I gotta hit green, go. And so now they can start running, and then as soon as it turns red, match is over, they stop. So now you as a coach don't have to sit there with your cell phone and time them for every time when they're running. It can do that and just start. And even better yet, one of the things that we can do is, instead of maybe starting that when it starts, we could go over here and do a when the touch LED is pressed. Okay, so here they hit start and it does everything, and let's say the maybe the LED stays off, but, or maybe we want it, where'd looks go, looks, we want the LED color to be blue, right? Okay, so it's blue until they press it, and then it's going to wait 3 seconds, turn green, and then 60 seconds later turn red. Okay, so we hit, well, not run, we got to make sure we download first. Now we hit run, And there we go. The light turns blue. Push it. And 3, 2, 1. Oh, maybe I didn't push it. 3, 2, 1, green. There we go, green. And then 60 seconds later, it'll turn red. They know their match is done. Now let's add some semi-autonomous functionality. And what I mean by semi-autonomous is kind of autonomous functionality, such as the robot does some things on its own, but it does it when the user tells it to do it. So, it could be something as simple as, for example, here what we can do is push a button and tell the arm to go to a specific position, so it'll actually go to a position. Or maybe you push a button and it goes to a position, it picks something up, goes to another position, and then backs up a little bit. Or at the same time as it's picking something up, it moves forward or moves back to keep something aligned. Or it does multiple things at the same time, but based on what a user tells it to do, and then it'll do those types of things. So let's say, for example, the kids are really struggling with trying to line up the arm so that it fits inside there. Right now I have the arm kind of slow, but you can see here it's potentially a little tricky, and they spend a few seconds trying to get the arm at the right height so that a way when they go in to pick it up, it picks it up at the right height. So let's say instead we want to create a position here, such as like something kind of like right in that area where the arm can easily drop it and go at this position, and it can go in and pick it up at this position here, type of thing. So we can do this. The motors have encoders built in, and they keep track of their rotation. So we can use a command that says something like, if we go over here, arm. So there's things like arm up for 90 degrees or 90 turns, or whatever sort of unit we want there. We can say for it to go up that much, or we can even say to go to this particular position or something like that, right? The question is, though, how much does it need to go up? And that's what we don't know right now. But there's a nice little feature we can add. We can have the display on the screen show us what that position is. And so what we're going to do, let's go over here to looks, and we're going to say put a print statement and say, instead of printing hello, which we could print hello, that's friendly, but let's print the arm position, okay? Semicolon and space there. Now what I'm going to do, I need to put another print statement in there, but instead of printing some text, I scroll down to sensing, and I got an option here for arm position in degrees, okay? So I could print arm position, and then it'll print this value, the arm position in degrees or rotations, or if I had different motors, I could select different motors here. You can see there's also an option for I could print the velocity of the motor, I could print the current of the motor, which is pretty cool because the current shows you how much force. Current is very proportional to torque, so that's like telling you how much force is on the motor, which is good to know in some cases and things like that. But anyway, this is going to print the position. Now if I run this program, it's going to print out the position, but it's only going to print the position once, right, at the beginning of the program. But then I'm going to move the arm, and it's never going to print it again. So what I need to do over here, I need to go to control, and here I'm going to use one of those forever loops, and I'm going to stick all of that stuff inside the forever. So it's going to forever print this. Well, actually, it's going to set for. Let's get that out of there. Put that in there. Let's get the touch LED. We just need to do that once. Print the arm position, or print the text, and then it's going to print the position. Now, one thing also when it comes to looks, we are going to want to do something like clear the screen. This clears all rows, and then we're going to want to, and when it clears it, we're going to need to also set the position of the text back up to the top, or the first row, first column type of thing, so then it always just prints. And so this will keep going and keep printing the thing. Let's hit download, and let's hit run. And now, if I look on the screen, it is saying arm position 0. I push the button. It's arm position 161, position -35, position -123. So now what I can do is I can line this up and then read what it says. However, there's one little gotcha in this with this program, and that is that position that it says is the value that it was when the program started. So you saw that arm when we started the program, the arm was in this position. Let me shut off the program. There we go. Now, if I drop the arm, run the program, now that position says it's 0. Okay, let me stop the program. Put the arm up here, run the program. Now that position says it's 0, right? So we really need to be careful and make sure this arm starts in the, if we start doing this, we need to make sure the arm starts in the same position every time. Oops, turned it all the way off. Let's turn it back on. So one of the features we can do there, we can, at the beginning of the program up here, we can just tell the arm, let's just tell the arm to go down. Let's go to motion, arm. Let's tell the arm to go down, and let's tell it to go down for a couple seconds. Let's just say 3 seconds or something. Actually probably 2 seconds is about all we need. Okay, so now it's going to go down and it's going to hit that bottom. Okay, because it's going to stop, we probably really want to limit its torque. So up here we have the torque set at 100. Probably to move it down, 25% is probably about all of the power we need to make it go down. Then it's going to hit the bottom. Go back to motion. Let's tell the arm to stop. Then let's tell it to... now here's the thing that we need. Here we go. Arm position to 0. So now it's going to go down. It's going to hit the bottom of the robot and basically not be able to go any further. And then it's going to time out after 2 seconds. Then we're going to tell the motor to stop. Then we're going to set its position to 0. So now always in this down position, the position will be 0. And then, before we continue on, we want to go back and set its torque back up to 100%. Okay, so that way it's back at 100%. Now, the other cool thing that we should maybe consider doing, that touch LED, let's have it turn blue after this. Okay, so it's going to go through this initial setup and stuff, and then the light's going to turn on. So now we know, don't touch the robot, or the robot's not ready until after it does this little initialization, and then it turns. And then after that, we can start a little forever loop of showing the position. So of course not. Okay, there we go. I got the arm to stay in that spot. Let's hit download. And let's hit run. Arm goes down. And did we see the light turn on? Oh yes, light turned on. And it's green to go. Now, one of the things also, let's see here. Let's actually, so we don't hold it in that hard position, let's tell it to not turn holding on until after all this is done, after we've reset the position and stuff like that. So now if we do this, let's hit run. Whoop, yeah, die down on. Okay, so I heard the motor kind of release a little bit, so it's not really pushing hard against there. Okay, so now it says position arm 4. Okay, so that's close to 0, and that's good. Let's move it up. Let's say that's the spot, kind of halfway in between there. And it reads 173, okay? So 173 degrees. So now what we want to do, let's say when we press this E down button, we want it to go to 173 degrees. So we can say events when controller button right here, when controller button E down is pressed, then we go to motion, arm. Now we don't want it to go up that many degrees. We want it to go to that position because it could be anywhere. The arm could be in any location, and we want it to not move by a certain amount. We want it to move to a specific spot, and we said 173, I believe is what I recall. And so there we go. Now let's try this out. Let's hit download. Let's hit run. There we go. Drop the arm down. Reset, turn purple. Now let's hit the E button and boom, there it goes. I'm going to hit this other button to call it to raise up and lower. Let's go to this spot. Now let's hit the E button again. Boom, right there to the middle. Let's go, say right there. Hit the E button. Boom, it's right there. So that gives us the perfect level to always be able to go in to the object, so that way we can pick it up and move it up. So you could do, and you can create many different positions like this. And for, each different button, you could have a different position to tell it to go to the upper position. In this case, this is as high as the arm goes. So, it doesn't really matter too much. But we could create different positions. We could do this for the claw, for example. If we had a claw, we could have an open position and a closed position, and we could just tell it to go to those positions when you push a button versus telling it to, move at a certain velocity open or certain velocity closed or something like that. See? And there we go. Push the E button and it sets it down, drops it right at the right position so we can back straight out of it. So this is an example of what I would call semi-autonomous functionality. And you can see how you could make this more complicated to kind of expand, if you had a more complicated robot to do more things, so that this saves time as the student. So instead of them driving up and having to kind of fiddle with getting the arm at the right position, now they can just push a button and boom, it's there, it's at the right spot. I want to mention, when it comes to writing code, there are always many ways of writing the same code or making different ways of writing it that will do the same thing. For example, here with the Vex code, we have, for talk about arm movements and stuff like that, you could, like we showed it, we could configure it in the controller here, where we have we can select buttons over here in the graphical thing to tell it what to do when we push this, for the claw to open or close, or the arm to go up and down. We could also create these events, which you saw before. When we pushed a button, that's when we wanted it to go to a certain position. But likewise here, when the E up is pressed here, the arm goes up. we could over here say controller, when controller button, well actually I used L up. So like over here, instead of using these two buttons, like we did with the arm, in this case it shows claw, but when we press the L up button, this tells it to open, or we could press the when controller button L up is pressed, spin claw open, and then when it is released, tell it to stop. Then when the down button L down is pressed, tell it to go closed, or in this case it's the claw, or if we were using the arm we could tell it to go down. When the button L down is released, stop. So these two programs do the same thing. Likewise, over here there's what we call kind of loop control. So this is an event. When an event happens, it does this certain thing. Over here we just say forever, let's just check. If the controller button is pressed, then we want to do this. Else, if this down is pressed, then we want to go down. Otherwise, if neither one of these are pressed, we want to stop, right? And we could just continuously check this in a loop. We poll to see if these buttons are pressed, and if they are, then we do something or don't do something. So there's many different ways here of being able to do things. And so like in here where whoops, not on the drivetrain, but on the controller, instead of putting these things here, we could over here do a when controller L up is pressed, then spin arm up type of thing, and when it's released we can tell it to stop. And so we can write these commands over here and make it do this, but then if we do set this up over here, we need to make sure we get rid of it over here. Okay, so likewise you can do this way, or this way, but you don't want to do them at the same time for the same motor. Okay, you don't want over here the L button telling the thing to open, but over here the L button telling it to do something else, or things like that. So pick one or the other, but don't really mix them, because if you mix them, you can get into a lot of situations where you got something telling it to stop at the same time it's telling it to go, right? And so if you have two different things, two parents telling the same kid to do different things, the poor kid just gets unhappy, and in this case the motor gets unhappy. So I just want to mention there are multiple ways of being able to write this code, and depending on, and each one has advantages, and depending on what you're wanting to do, maybe you want to make the arm so that it goes up really fast, but then it goes down slowly, right? And so you can set its speed, but that speed is, or up here the velocity, but that velocity is set for both going up and down. So over here maybe you can say when it's pushed up, set the speed equal to 50, and then go up, and then when it's pressed down, set the speed equal to, if you want it to go down slow, 25 or whatever, and then go down, and then get rid of it over here in the controller section. So, there's a lot of different options there when it comes to how you program things. And as you get more advanced, you'll probably use less configurations over here and more setup of loop control or event-driven stuff and things like that. Now that we have this great little driver program, I want to show you just how easy it is to now create an autonomous program. And I really want to emphasize the importance and the value of autonomous programs and programming in general. During the matches, and at tournaments, only the #1 ranked team or alliance, the two teams, qualify for state to go on to the next step. But at the end of the season, based on how many spots are available, they take as many as 50 teams or more based on the skills ranking scores. And so that is a very good way for a team to not have to be burdened by the randomness of the tournaments and the randomness of whose partners they have, the partners that they have, and whether they had a good day or bad day. This is their opportunity to, with their driver's skills and with their programming skills, get ranked very high in the state and qualify for the state championship that way. Also, computer programming in general, is probably one of the highest paying jobs out there for simply a 4-year degree. Programmers starting at Apple, at Facebook, at Google, at any of these other companies in any place make really, really good money. And so I can't emphasize enough how valuable programming is. And quite frankly, computers are all around us in the world, and the only way not to be a slave to a computer is to know how to program it and make it do what you want it to do, and so you don't have to just do what it expects you to do all the time. So anyway, programming, very important. Autonomous programming, very important for the tournament, very important for life skills for the students, and it's very easy to do. So we have this driver program. First thing to do, go over here and let's go to File, and let's just save a copy, and instead of calling this drive or bot drive, let's call it bot auto, AUTO. Okay, so now we have this program called bot auto. Let's also, now while we're thinking of it, let's change its slot to slot 2, okay? So that way when we program it to the brain, we don't override it, the bot driver. So, because we want to be able to drive, and we want to be able to run our autonomous program and be able to switch back and forth. So let's try not to override those two. So we have bot auto. Now, the big difference with an autonomous program is we don't have a controller over here. Okay, so this controller, we need to click on delete. Now, the reason why we got to delete it out of here is because if it's there, the program will expect it, and the program won't run without it being on, which means if you want to run your autonomous, you have to turn on your controller. Well, that's actually not legal in tournaments to be having your controller on during an autonomous program. So you need to have it removed. Now we still have, for example, over here we have when controller button is pressed, and if we tried to download and run the thing right now, it would give us an error. So we got to get rid of that stuff. We got to get rid of any sort of places where we talk about the controller. Otherwise it'll give us a compiler error. But we'll do that in a moment. So now we have when start. We'd go through all these things. Then when the LED is pressed, right now we're using it for a timer sort of thing. Let's get rid of that. Okay, we'll just plunk delete all that. And over here, after it goes through its initialization, let's tell it to turn green. That's a nice color, I like, indicating that it's ready to go. And so now when we push the touch LED, we want to tell it to drive, okay? So over here for drivetrain, we don't want to use the drive forward, because then we have to tell it to drive forward, wait for a few seconds, and then tell it to stop. There is this nice command here that says drive forward for so many inches, or we could change that to millimeters, but the field's in inches, so let's stick with inches. So we got this command right here. Let's delete that one. Drive forward 1 inch. Well, let's change this to drive forward for, say, 6 inches. Okay, so let's see how far it actually goes and what it does there. When controller button down, darn. Okay, so we got arm position 173. I'm going to write down that 173, and let's get rid of this. And I don't know if I can comment this out or not. Let's see if this compiles. Oh, I got to turn on the robot. Robot is on. Hit download. Okay, downloaded, and then let's hit run. Doing its initialization. Let's move these out of the way, and let's hit start. Okay, so that moved, but it seems like it moved a lot further than 6 inches. So what we can do, let's go over here. Let's look at our drivetrain, and so gear ratio. So now actually this robot here, if we look at its drive system, it has, let's see if I can get here, let's look at it from the bottom. There we go. So it actually has a big gear connected to the motor with 2 little gears on each wheel. These are, I happen to know, this is a 48 tooth gear, this is a 24 tooth gear. So we have a ratio of 48 to 24, or if we do a little simplification, we have a gear ratio of 2 to 1. So let's tell it we have a gear ratio of 2 to 1. And then I gotta move this out of the way a little bit. Let's hit done. And now download, run. Okay, that looked closer to 6 inches. Let's see if I can get a ruler out. Well, I don't have a ruler. I have my digital caliper, so we can measure down to 1/1000th of an inch how accurate it is to the 6 inches. There's 6 inches. Touch the LED, and that looks pretty darn good. That looks 6 inches to me. Oh, am I off the screen? Sorry about that. Okay, there we go. So I got the calipers on there. I just measured from the front of the robot. Push the button, and it moves 6 inches. Okay, so now we got the distance calibrated. We got our program doing that. Now let's work on rotation. So with rotation, we have turn right 90 degrees. So for right now, let's just get this drive forward out of the way. I'll stick it over here. Turn right 90 degrees. Let's tell it to turn right 90 degrees and see what happens. Download. And run. Okay, so that's not bad. It's a little bit over. So let's go to drivetrain. So the track width is what defines that arc of the turn. So it went too far, meaning that it kind of thought it was too wide. Let's make this, let's say 160 or something like that. Make it a little bit smaller. Done. I guess I can just move this over here for now. And download. And let's square it up nice and clean. There we go. Now I gotta be careful. I still have this USB cable plugged in there. I really don't want to rip that off. Run it. And there we go. Looks like it still went a little far. I can go back to drivetrain. Let's make this 150. Done. Download. Run. Green light. Push it. Ah, that's good. That's good enough. Okay. So now we got turning calibrated, we got the distance calibrated, we got turning calibrated. Now let's start picking some stuff up here, okay? Let's set these here in some location just to keep things simple. Okay. Now. So what we want to do with our program here is we want to drive forward, and actually we want to pick this thing up. We need to tell it to go to this position first, right here. So what we need to do is I can take this code, arm go to position 173, and then I can tell it to drive forward type of thing, and something like that would work. But let's instead, for this arm position, let's create an event over here and say when I receive a message, and let's say new message, and let's call this the arm let's call this arm down position, because this is kind of where we're going to be setting down the game elements. So arm down position. It's not like the 0 position down on the ground, but it's that position. So now what I can do is over here I can say when it's touched, I want to broadcast arm down position. Actually, there's another one for I think we want to use right now. Broadcast arm down and wait. Okay, so we need to wait for it to finish what's in this code, which is so that it gets up to that position. Then we can tell it to drive forward 6 inches. Then we need to tell it to go up. Okay, now what I should have done in the driver program is figured out what the up position was. And looked on the screen, and now I'm going to have to guess since I don't have it. So let's create another when I receive message new arm up. And for that, we're going to go to motion, spin to position, and I'm just going to guess, let's say 300. Let's just say 300. That could be too much. It could be too little. It would have been nice. Or I could actually, I can just go run on slot 2. Let's do this. I'm going to go run. I'm going to go select my driver program. There we go. Turn on my joystick. Let's press E. There we go. Whoops, make sure I didn't push that button too quickly there. Okay, now I got the green light. E. There we go. Pull in. Go up. And let's call that the up position, and it says 338. Can I go higher? No, not really. So let's go down a little bit. 320. There we go. So it says 320. So that's what I'm going to use. I'm going to stop that program. Turn off the joystick since I shouldn't need that now. Okay. 320 is what we can use for that. There we go. So now, broadcast arm down. We move forward 6 inches. We want to broadcast and wait. Let's say arm up. Right there, arm up. Okay. Then let's see here. We go up. After we go up, let's go back 6 inches. Okay. Drive train drive, reverse 6 inches. Okay, so let's just try this code and see what it does. I'm going to hit download and run. Does its calibration, light turns green, push it, arm goes up, goes forward, lifts up. Okay, so it didn't go up it didn't go forward as far as I wanted. That's really my positioning, but you can see there, lifted it up. Now, let's actually make it do a little bit more. So we want it to lift up from there. Let's actually go ahead and stop this. So it lifts up from there. Let's turn right 90 degrees. Let's go forward, say 4 inches. Let's put it down. So broadcast. Let's get some more room here. Oh, I just deleted that. I think I can do Control Z. There we go. Okay. Don't drag it into that command area or it'll go bye-bye. Let's just move this stuff down a little bit. Give me some more space. Okay. Forward 4 inches. Events. Broadcast. Well, let's just do broadcast and wait. Arm down. Then we want to drive reverse 4 inches. Okay. And then we want to turn, nope, not drive. We want to turn left 90 degrees. Okay. So let's see what that does here. Let's download it. I gotta get this out of here. Hit run. Okay, let's get it lined up here. Something maybe like that. Okay. Start. There we go. Drives forward, picks it up, backs up, turns, goes forward, drops it down. Wow. Look at that. Like it was born and made to do that. Okay. So, now let's come over here after that and let's try and pick up this guy. Okay. So, from there, let's say we're going to need to go forward. Boy, that looks more like 18 inches. And then we're going to go up. Oh, actually, well, yeah, we're at the right spot now. So now we can go arm up. And then let's, what do we want to do from there? Let's go back. If I had a field, then we could actually do something that scored points. But let's go reverse. Let's just say 6 inches. And then turn right 90 degrees. Then let's keep making ourselves some more space here. Move these down. Turn right 90 degrees. Then let's go forward 4 inches. Let's drop it down to the arm down position. And then let's go drive backwards, reverse 4 inches, and then turn left 90 degrees. And then just for looks, where's looks? Let's do a couple things. Let's turn the LED off, and let's play a sound. How about that when we're all done? What do we want? Well, sirens. Ta-da. There we go. Ta-da. Okay. And we can get rid of this guy. Okay, so I think we got a lot of steps in here. You can see how it starts to grow. And I don't really have a field to precisely set things up on, so we'll see how well that does. Let's hit download. Set this there. I think that's going to need to go about here. I have to be pretty close. And then that one's going to have to be, let's just say, actually, let's move all these forward a little bit. Okay. Did I hit download? I think I did. Now, for this one, I'm going to go ahead and unplug my USB cable since we're doing a whole bunch of movement. And I'm going to hit run. Okay, it does its calibration. Light turns green. Let's line this up a little better. Make it. Oh, look at that. How about that? Does it get any better than that? Lastly, I'd like to talk about the sensors. I don't want to go into great detail on how to use them and that, but I do want to give you some basic understanding so when the kids ask, hey, what is this? How does this work? What does it do? That sort of thing. You can at least give them a little bit of an answer. So we talked about the touch LED. Actually, it has two features. It can light up and change to whatever color. It has an RGB LED inside there for being able to change to any color. And then it also has a capacitive touch sensor at the top, so it detects when you touch it. For example, it's capacitive, and I don't have any, here's a plastic stick. It will not detect when plastic touches it or something else that is an insulator. It has to be somewhat conductive, and it can detect when things are touched. And you saw in the program how to, add a condition. If this is touched, then, do this or do that. Here is a button. This is just simply internally. It just has nothing more than a switch. It's like the one sensor that actually doesn't have firmware in it to be updated. So you don't have to worry about plugging these in because there's nothing they can do to update these. But this one will detect plastic hitting it. So you could use this as a bumper for an arm coming down or something and detecting when it gets down and things like that. Okay, this is the light sensor. It has the ability to detect colors, basic colors. So, sometimes you have orange and blue and different colored objects and game elements. You might be able to detect the difference between those. It also has the ability to detect light and dark. So on a field where you have this black squares, this is great for kind of being able to detect when you come to one of those black lines and know how far. You hear people talk about using it as a line follower, so you can write a program so that it kind of follows a line. In the competition, you're not going to be so much following a line, but you may use this for detecting when you get to one of the lines, so you know how far you are and where you're at on the field and that sort of thing. So it's potentially useful for that. The gyro. So you heard me in the drivetrain system. There's an option to use a gyro. So what a gyro does, it's a short for gyroscope. it measures the rate of rotation. In other words, how fast, how many RPMs it's turning. Okay, so it doesn't actually measure the angle that it's at, it measures the rate at which it's turning. Now what the software will do is take that and integrate that, for those that remember your calculus, they will integrate that value such that you can integrate that rate to get a position so it knows whether you're here or there. The problem with this is you do have drift. So for example, if your robot's not moving, and instead of it measuring 0, it measures 0.001, what that means is it's going to be adding, and so it doesn't think it's at 0, it thinks it's just turning a little bit, 0.001, right? And so it's then going to be slowly adding that up, and it's going to make it think that the robot is actually kind of slowly turning. So over a period of time, such as 60 seconds, the time of the match, it could, instead of thinking this is 0, it could think that it's actually angled this way, right? So you run into some issues with that with using it, but it is otherwise, it's handy because no matter how much the wheels slip and things like that, this can still measure how much the thing turned. We have also here, this is the distance sensor. It is an ultrasonic sensor, so it uses one of these to send out an audible ping. It listens to the echo as the audio hits a wall, a surface, usually something hard reflects sound better, and the sound reflects back and comes into the microphone side, and it uses the time that it takes the audio to hit and reflect and measures that time to determine the distance. This is good. You got to be careful so it doesn't pick up false positives on stuff, and depending on what the size of the object, the side of the wall of the field, for example, it can pick up and nicely, but it has a limited range. So once it gets so close, it can't measure, and once it's so far away, it can't measure either. It also is a little bit sensitive to noise. So at tournaments where you just got an extreme amount of background noise and things like that, these can be a little bit problematic in tournaments and things. So they're not used a whole lot. Actually, the motor too technically counts as a sensor because it has an encoder in there that measures the rotations. It also has the ability to measure its current draw that the motor's drawing, so you can kind of relate that to torque. So that's the basics of the sensors. When you kind of get into some of the advanced programming, maybe you'll use them a little bit more.